The overall goal of this investigation is to develop electrospray film deposition of chalcogenide glasses for mid-infrared photonic applications and to explore the unique flexibility of this deposition method.
The main advantages of this technique are that it allows localized deposition of material, with the ability to fabricate an engineered film thickness profile. This makes it possible to create a spatially varying compositional gradient.
Due to these advantages, electrospray can advance the field of chip-based mid-infrared chemical sensing devices by allowing more flexible device design.
To set up the deposition process, first place the end of the needle into the chalcogenide glass. Draw the solution into the syringe by setting the syringe pump to extract mode at a slow rate, such as 150 microliters per hour, to prevent the formation of bubbles. Set the working distance between the end of the nozzle and the top of the silicon substrate by using the computer numerical control in manual movement mode. Place the silicon substrate on an aluminum plate connected to the power supply ground return. Then, dispense some liquid from the syringe utilizing the syringe pump to allow a small volume of liquid to coat the outside surface of the nozzle. Turn the hot plate on at a surface temperature of about 75 to 100 degrees Celsius. Wait for approximately 2 hours to allow a film of glass to dry on the nozzle surface. Connect the direct current, or DC, power supply to the syringe nozzle with an electrical clip. Set the flow rate at 10 microliters.